Eu să trecem în engleză. So, hey guys, welcome to the English shit. So let's start with the presentation. So we'll start with the first question, and the first question would be, what is imperative style programming? And let's try to define it. So, well, this is what Wikipedia says, and it's a programming paradigm that uses statements that change program state. Not very helpful, right? It seems to be kind of too abstract, for me at least. So let's try to keep it a little bit more simple though. It's when we design the path our program have to follow in order to achieve our desired state. So kind of we dictate the path, and it usually looks like this, and you can see that we dictate him every single step it has to follow. Like do this, then do this, then do that, then take something from there, then put something over there, and so on. Let's take as an example some Elixir code. So this is a module responsible for creating a new user. And we can see that we define every single and every little step it needs. Like, firstly, it has to validate the email. Then it has to validate the username. Then it has to validate the password. Then it has to store the user inside the database. Then an email should be sent. Then it should return the created user. So this is an imperative style programming. Like, we define the steps that have to be followed. The same example in JavaScript would look like this. So again, first it validates the email, then it validates the username, then it validates the password, then it stores the user inside database, then it sends an email to the created user, and then the stored user is returned. And again, this is an imperative style programming. We define the steps to be followed, and all of those validate email, validate username, validate password functions, they would also be defined by us. Okay, what is declarative style programming? And again, this is what Wikipedia says. It's a way to build the structure and elements of computer programs without describing its control flow. So yeah, this one is easier to understand versus the previous one, but anyhow, let's try to simplify this one also. So mostly it's a way to say this to our computer. It's like, man, I want this, and I don't care how you achieve it. So it's a way to say our program, how should it look like? And we don't care about the road it uses to reach our desired state. We just define the structure. Let's take as an example some Helm charts here. So this is a Helm chart from MySQL deployment. And we can see that we do not define the way anymore. All we do is to define the structure we desire. Like, we want a container that uses a specific image. Then we want to use some environment variables for it. Then we want to have some exposed ports from inside our pod. Then we want to have some volumes mounted inside our pod. Then we want to have some labels attached to our deployment. And in the end, we might also want a name for it. So another probably more familiar declarative language for us would be this one. And as we can see here, we are defining a title for our website, then we define a title for our page, then we define a paragraph, then we define a button, then we define another paragraph. And we really don't care about the way they will be rendered or about the background technique that will be used for that. Is it OpenGL? Is it DirectX? Is it something else? We don't care. All we do is to declare the structure we desire. So for comparison, we have a little RAM here. So a real life example of the imperative style would be the one from the left side. Imagine you ask somebody to bring you a glass of water by saying him, okay, stand up, walk 10 steps, buy your food to the fridge, use your hand to open the door, get me the water, walk back 10 steps, give me the water using your right hand, wait until I take the water. A declarative style example, on the other hand, would be something like, honey, I wish I had a glass of cold water, please. And that's all. Like somebody else will think about those steps for us. We just don't care about them. So the imperative style programming is the ability to tell the machine how to do something in order to achieve our desire. The declarative style programming, on the other hand, is the ability to tell the machine what's our desire, but letting it to figure it out how to achieve it. Good. What is lazy loading? And again, this is what Wikipedia says. A way to defer initialization of an object until it's really needed. So the object won't be initialized at runtime, I mean, until somebody will request for it, right? An example of lazy loading would be this one. We have a variable by default initialized with null. We initialize it only if it's null, and in the end we return it. And the second time we invoke this function, the if statement won't pass and we would just return the earlier fetched value. So we won't make two calls to server, but just a single one. Okay, what is a flow? Like, let's try to define it. What's it? Is it an object? Does it have a color? Does it have a shape? And again, this is what Google says. So it's something in a continuously unpredictable or unpredictable motion, right? Something that has the ability to move, right? And it usually has an approximate path. So we usually use this word in IT, I mean, by trying to describe the way our data is manipulated by our programs, right? The flow, we say, the business flow, right? We might also use it for so-named user flow or user experience flow, but in the end, it's mostly the same. It's the way the data is manipulated by the business logic. So we have the data and we have the business logic, and the data flows through the business logic, right? And as far as we are talking about flowing, and we also have seen this little keyword here. Let's see what's a stream. So again, this is what Wikipedia says. It's a sequence of data elements made available over time. So we have two variables here, right? We have the data and we have the time. Now, because of those variables, the data and the time, streams can have potentially unlimited data. So we don't know when it finishes. All we know is that from time to time, we will get some data. And all we can do is to handle the data. Let's take two users. One tries to send a message to the second one. They are over the internet, so delays might occur based on their internet connection, of course. So the first user have to wait until all the data is received. So the data can come over the time, right? So how do you think what's used in between? Streams, of course. Let's take a hard drive and a computer. Let's say the computer wants to read something from the hard drive. We don't know the hard drive's physical capabilities, right? You have no idea how much time it takes for the hard drive to read at least one single byte. You also don't know about the external factors that hard drive might be exposed to. You also might not know about its storage capability and so on. So there are a lot of stuff that can influence the time and the result. So stream is used. Let's take a computer and a mouse. The computer has no idea when the user will use the mouse. The mouse interruptions will come randomly in time whenever the user decides. So again, there are a lot of external factors that influence the time at data will come. And again, stream can be used. Let's take some C# examples now. And well, this is not a perfect representation of a stream as it's fully hidden under a lot of syntactic sugar and libraries. But anyhow, this is how we would use a stream to read all the data from a file in .NET. So we declare a stream. We create a reader over that stream. And we use the reader to iterate and collect data from that stream. What's important here is that we don't know how big is that file. And if it's too big, we surely can get an out of memory exception. We also don't know how much time will it take. It all depends on a lot of external factors. Is it an SSD? Is it an HDD? Am I the single consumer of that hard drive, or is there somebody else using it? We also don't know if operation will fail or succeed. Will the power go off? Will my hard drive just break? Will somebody just unplug it? And so on. So yeah, there are a lot of external factors that influence directly or not directly the time and the result. Let's see now why do we need streams? So streams are very useful for handling in special input-output devices, unmanaged resources, and delayed data and data with interferences, right? So mostly everything that's dependent on the time variable. And whenever we don't know when the data will come to us, something like that. Okay. So what is reactive style programming? Okay, we've talked about imperative style programming. We've talked about declarative style programming, lazy loading, flows and streams. So how do you think now, what is the reactive style programming? Well, our Sherlock deduction would say that, yeah, we should somehow combine the previous definitions, right? So this is what Wikipedia says. It's a declarative programming paradigm concerned with data streams and propagation of change. And yeah, well, this one seems also to be an easy definition, except for the last part with that strange propagation of change, of course. But let's try to simplify this one also. So, it's the ability to declare our business flow by using streams and lazy loading over an imperative style programming. In other words, we declare our business flow in an imperative language. And yeah, by using streams and lazy loading in different proportions. So it's a way to simulate declaration in an imperative language. And for this one, a combination of at least the keywords we've talked about before is needed. So why the fuck it's used on web then, right? Well, as far as browser are directed to client side usage only, there was a need for fetching data. And as far as the internet is a huge unmanaged resource, streams is the one that is one of the best words that fits well here, right? And the most appropriate technique that manipulates streams is reactive programming, right? So promises appeared. Well, they also appeared in order to restrict the access to machines' resources for security reasons. But that's another story. In the end, promises are here and they are kind of reactive. Here we have a JavaScript example. It tries to fetch the current user and print its role. And if an error occurs, it prints an error. So this is the declarative part. And this is the imperative part. And this one is kind of the lazy loading part. It's not actually lazy loading here. It's more like a combination between memoization and dependency injection. But for making it easier to understand, let's name it just lazy loading. So the print role and print error functions won't be executed until the data comes. But the problem with promises is that they are kind of pretty primitive. So in order to do some complex business logic with them, you have to write a lot of boring boilerplate, especially when you have to manipulate a lot of asynchronous flows. So let's take this lovely pyramid of doom as an example. And this one is a simple synchronous example. Imagine what happens when stuff goes asynchronously. Like you have to wait 3 streams to end, and then the 4th one will do some other asynchronous stuff, and then you have to wait until until the 4th one, and you can just trigger 5 more asynchronous operations and so on. So things goes crazy. Okay, what came next? Well, then some smart people tried to eliminate this boilerplate, right? So they invented a standard, and they named it Reactive X. And this is the definition from Wikipedia, and it's a set of tools allowing imperative programming languages to operate on sync or async data. Okay. It provides a sequence, a set of sequence operators that operate on each item in the sequence, right? So we have some operators we can use to manipulate the data. And it is an implementation of reactive programming and provides a blueprint for the tools to be implemented in multiple programming languages. So it's a standard, right? Like GraphQL, it's just a standard. And developers can implement libraries over this standard in different languages. And as far as we've talked about those smart guys that invented it, this is the author. And we can see here the reactive X libraries for different languages. And one of them is JavaScript. And the JavaScript library that implements reactive X standard is named RxJs. Okay, so let's jump on the RxJs then. RxJs is composed of different parts, and those are streams, observable pattern, pipelines, and operators, and a lot of operators. And operators are the most important part here, so let's talk about them. RxJS operators are grouped into categories by their purpose. So those categories are creation operators, join creation operators, transforming operators, filtering operators, join operators, multicasting operators, error handling operators, utility operators, conditional and Boolean operators, mathematical and aggregate operators. Well, we're not going to talk about everyone. We simply don't have enough time for that, but we will take some examples and we will try to use different operators from different categories for trying to solve some proposed problems. So, RxJS pipelines. But before we can do that, because we can jump on some examples, let's have a look on the way those operators are used. So in RxJS, all the operators are combined together into pipelines. And we can imagine a pipeline being a water pipeline. So the water is the data and it flows through the pipeline, right? And everything else that controls the flow of the water are operators. So operators are mainly used to manipulate, transform, and filter the data. And we don't know when the data will come. It's totally dependent on the time. So we have a stream here. Let's have a look over a pipeline structure now. So every pipeline have to start with a creation operator. That's the law. You always have to start it with a creation operator. Then we continue with some operators. And then we continue with other operators. And then we continue with other operators. And then we continue, guess what, with other operators. And so on. And in the end, in order to execute those pipelines, we have to use the subscribe. That's it. That's it mostly. Starting with the creation operator, continuing with any other operators, and subscribing in the end. So nothing would be executed until we invoke this subscribe method. An important thing to be said here is there are specific operators that allows us to chain multiple pipelines. So pipelines are composed of operators, and there are also specific operators that can chain multiple pipelines, like perfect polymorphism, right? Pipeline is a pipeline, but it's also an operator, something like that. Another important thing to be said here is that chain pipelines can be executed as synchronously as asynchronously. And we have a ton of operators for that. Okay. Now let's jump on some examples. Let's take some examples. Let's say we want to do the same thing we did before. We want to fetch the user and print its role. Otherwise, we want to print that error that occurred, right? So the code would look like this, and then let's try to analyze it. So first of all, we are starting with a creational operator. From is a creation operator that takes a promise and returns an observable pipeline. So in our case, this fetch function will return a promise, and from operator converts it into an observable pipeline. The next step would be to continue our pipeline with some other operators, right? So this is what the next line does. In order to continue a reactive pipeline with some operators, the pipe method has to be used. And the tap operator is an utility operator. And all it does is to call a void function with the input that comes from the stream. That's all. It doesn't change the flow. It just invokes, let's say, a function that has no output. That's all. So we are passing him a void function, and this function will be executed with the fetched user as a parameter. And this function is just a console log in our case. Now let's take the next step. It would be the error handling, right? So again, we are using the pipe method in order to continue a reactive pipeline with some more operators. The catch error operator is an error handling operator. And we pass in a function as a parameter. And that function have to return another reactive pipeline. The of operator is another creational operator. And all it does is to convert a static value into a reactive pipeline. The function we pass to catch error operator also receives the error as a parameter. So we can use it for different purposes. Okay, so we are using another pipeline as an error handler here. And this pipeline will be invoked whenever any error will occur in the main one. Now, you remember we've talked about lazy loading and the ability to declare business flow inside an imperative language. So until there, nothing will be executed yet. So nothing will be executed until we invoke the subscribe method of the pipeline. All the code till the line 20 is a declaration of our business flow. Nothing happens until we invoke the subscribe. I'll ignore the from fetch stuff. It might be a difference between cold and hot observable. We don't want to talk about them. Okay, a graphical representation of this flow would be this one. So first of all, we are fetching the user. Then if it's a success, we print its role. Otherwise, we print a failure. What's important to be said here is that everything is made synchronously here. I mean, nothing happens in parallel. Firstly, the user is fetched, then the respectively message is printed, respectively. I don't know how to spell it. So it's synchronously. Let's take another example. Let's say we want to fetch 2 users and print their roles, but in this case we would like to do fetching and printing of each user in parallel, like asynchronously. And then you remember how the previous code looked, right? This is the previous code. And this is how the new code would look like. And then there are only 2 changes made. And let's have a look over them, right? So again, this is the previous code. And this is the new code. Yeah, previous, new. So there are 2 changes made. And let's have a look on them. First of all, we've made our user ID to be configurable, right? So we could use it for different users. Then we've used the zip operator, and it is a join creation operator. It takes an array of pipelines, executes all of them in parallel, waits for every single one to finish, and only then continues the pipeline. Right? This one would be the graphical representation for the current flow. So we are operating with 2 users now, but this time we do it asynchronously. So we don't know which one will come first. Will it be the first one? Will it be the second one? We don't know. And because of that, we also don't know which one will be the first one printed, right? But what we know instead is that the zip operator will wait for all of those pipelines to finish, and only when all of them are finished, the next operators will be invoked with all of the data returned by previous pipelines. So this time we are doing stuff asynchronously. Okay, let's take another example. Let's say we want to fetch 3 users, but this time we want to print only the ones with the admin role. And this is how the code would look like. And let's try to analyze it. So first of all, we have a pipeline that fetches an user by ID, right? Like the previous one. And it returns an observable, and it's using the creation operator named from for that, the one we've used before. The code responsible for printing remains untouched, right? It's the same as in the previous example. We've used a new join creation operators here, and its name is merge. And it takes a various number of reactive pipelines as parameters, and its responsibility is to take all of them and merge their values into a single reactive pipeline, but synchronously. So in all of the next operators, we will get firstly the first user as a value, then the second one, and in the end, the third one, right? In the next step, we've used the filter operator, and as its name already says, it's a filtering operator. And as most of all operators, it takes a function as a parameter. This function is invoked with a value, and it should return a boolean. And it's used to filter the values that flows through the reactive pipeline. And if the value is true, the operator used after the filter one will receive that value, and otherwise that value will be just ignored. So in the end, our tab operator will receive only the users that has the admin role assigned to them. And as we've already discussed before, nothing happens until we invoke the subscribe method. Okay, this one would be the graphical representation of this pipeline. And now we are operating on 3 users, but this time we use the merge join creation operator, and unless zip1, it executes children synchronously. Well, there is a trick here. It would behave kind of asynchronously if any of our child pipes would have multiple values. So to be 100% sure that it's synchronously, we might have been used the concat join operator. But yeah, but as far as every child pipeline has only a single value, those two operators behaves in the same way. So
Yeah,
firstly, we'll
sorry. So I have a question here. So in this case, that you presented right now, I believe also zip operator could handle the job instead of merge, right? But you presented
we
merge.
didn't use merge yet here.
Yeah,
The merge one has been used before in the previous example.
I know, but for this example, the zip operation will also operator will also work, right?
No,
No.
the zip operator will make all of those 3 users here, like fetch, 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 you see?
Yeah.
It will behave asynchronously, like in parallel. The fetching of each user will be made in parallel. In this case, by using the merge join operator, the first user will be fetched. After that one has been fetched, the second user will be fetched. After that one has been fetched, the third user will be fetched.
Okay, makes sense. Yeah.
So that's what I mean by saying like synchronously, right? Because yes, we know it's made fully asynchronously on the web because we don't have that wait method like we have in C# on tasks and threads, right? But I mean what happens inside the pipeline. So the fetching is made one by one.
Yeah. Thank you.
So firstly, we will fetch our users one by one, right? And then for each fetched user, the condition will be executed. And based on the condition, we will continue with the success or failure pipelines. And again, the users are fetched synchronously one by one. Now let's take some example, but this time we would like to fetch the users asynchronously, but parsing them synchronously. So we have to somehow to combine those approaches, right? So this is how the code would look like. And all we did is to use zip operator instead of merge one. And then we use the from operator to continue with a single pipeline. Right. I might have missed here a merge map operator, but I think it also should work. And the rest of the code remains untouched. And those 2 little changes did this to our graphical representation of the flow. You see, now the user fetching is made in parallel. We are waiting for all of them to, yeah, they are asynchronously. We are waiting for all of them to finish the fetching. I don't know how to say that. So we are waiting until all of them are fetched. And then we start with filtering each of them. And then based on the condition, we choose to print user or to ignore it. Right? So this is a difference between the example before. where you asked me, Alex.
Yep.
Okay. Now there are much more RxJs operators than we've just used today. Now we don't have time for all of them, unfortunately, but let's at least enumerate their categories, right? So we have join creational operators, right? We have filtering operators. We have transformation operators. We have creation operators. We have join operators. We have multicasting operators. We have error handling operators. We have utility operators. We have conditional and Boolean operators. We have mathematical and aggregate operators. So there are some of them, right? Yeah, here are some references I've put here you can use to learn more about the stuff we've discussed today. Also, I've used them to create the definitions and stuff like that. And questions.
What about about casting operators? I'm not sure that I use this kind of operators.
Let me try to see them, to be honest. Neither do I. I know, yeah, they do something, but I haven't used them ever.
Okay.
Now, I know there are some other combinatory operators that are also very strange. You can use to create windows and stuff like that. But multicasting, I have no idea what does. Those would be the multicasting. Publish behavior, publish last, so on.
Yeah, so do you know what exhaust does? Or do?
Nah. Man, you are usually using kind of, I don't know, 10 of them all the time. You don't need like the rest of the operators you can use like in an edge case sometimes, like before the, I don't know, time ends, before the end of the earth.
maybe I picked the most exotic ones. So yeah.
Yeah, actually, to be honest, most of them are exotic here. I mean, have you ever used pluck operator or scan?
I kind of
have it both.
It's an easy one, right?
Yeah.
It just returns a value from an inner object, right?
Exactly.
But, come on, timer. Have you used timer? EF. Have you used? You know that this one is just a if else statement.
No.
Bind callback. Have you used that? Bind node callback. That's more. This is binding a node.
I would actually have a question though. When a pipe emits a value, it emits just a value, right? Not a reference, correct?
Well, no, depends. You can emit the reference also. In JavaScript.
I mean by default in JavaScript. So without any digging around, default behavior, I mean. So for example, if I have an off object, right? And then I put a tap and I modify a value inside the object emitted, it won't be modified after the tap, correct?
I'm not sure here, but I have a doubt that it might be changed in the next pipeline.
We have to try that shit out.
Yeah, I'm not sure if they like do stuff like immutability inside because the simple fact is that they don't know what you're using as your pipeline values as the data that flows through the stream. You might use a stream there. Try that. Try to make a stream immutable.
Yeah, good luck.
A file stream on Node.js, for instance. The
Yeah,
one
but
that we've used just to read a file.
the do operator in Rx.net modifies the value. So
Which
that
one?
I'm sure. The do operator.
Yeah, well, .NET was not made for reactive programming, unfortunately. But yeah, it's as far as the reference type, you should be able to change the value from inside the tab. There also might be the possibility that there are some operators that makes the value immutable, but we have to search them through all of this hell.
Yeah, good luck with that.
Default is empty. This one is used. Every also used. Is empty also used. Yeah. So, do you have any other questions?
Nope, not here.
Nothing.
Thank you for your